Hey, Will. Hey, Will. Hey, Will. How can I cryogenically freeze myself? And if I do that, when they wake me up, will I still be alive? Because if not, that kind of defeats the whole purpose, doesn't it?
Good question. Hi, I'm Will Tokes. Welcome to What Would You Like to Learn Today? So BJ, what you're talking about here is cryonics, which is basically the study of how we can take a living organism, or portions thereof, take it down to a very cold temperature where it's held in a state of suspended animation. Or in the case of what we're about to discuss here, just simply being frozen. So there are a couple of things in the way here that you should be aware of before you go out and buy yourself a policy. First of all, there's the cost. The current rates that is charged by Alcor Life Extension Corporation, founded in 1972. $150,000 if you want to get your whole body frozen, but it's $80,000 if you just want the head. So they're going to freeze you and then they're going to get you a new body. We're still working on that part. Anyway, so when we're talking about freezing somebody, there's a couple of physiological problems, all right? So, all right, let's talk about cells, okay? So in your body, you got to think about there's all these cells that are growing, and in between the cells is space, okay? There's space between the cells, and then there's space in the cells themselves. And generally speaking, it's all made of water, right? Everybody knows human beings are mostly water. What happens is that when you get something cold enough, when you get a piece of animal tissue cold enough, ice starts to form. Now, typically when ice starts to form, it's going to start forming in the interstitial spaces, also known as the extracellular space, okay? And it forms little crystals, okay, and as it gets colder and colder, those crystals are going to continue to grow and get larger. Now, this has a number of negative effects. First of all, as the ice forms, it's going to form pure ice, and it's going to exclude all the solutes that are dissolved in it, all right? And what that means is that those solutes are going to become concentrated, and some of them are toxic in concentrated form. Number two, ice takes up more volume when it's frozen. The same amount of water is 10% bigger when it's frozen than when it's liquid. So what that means is as all this ice keeps freezing, it's going to start squeezing on the cells, and it's going to begin to crush them. Lastly, there's another corresponding problem, which is as the ice forms, right, and you get concentration of solutes, that's going to create an osmotic pressure that's going to draw water out of the cells and thus dehydrating them. Finally, if this keeps going, you're going to get ice formation inside the cells, and when that happens, that is instantly lethal to the cell. They cannot handle that kind of ice formation. So, we've come up with some ways around this, all right? So we can't freeze you straight. We can't just stick you in the freezer, all right? You're going to get freezer burn, and we're not going to be able to wake you up. So what we're doing instead, here's the plan. Let's say that you're out on the town, all right? And you're wearing your usual sartorial combination of purple pants and a ridiculous hat. And you have some kind of misadventure, and it doesn't turn out that well, and you die. You're wearing your little med alert bracelet right here that says, please call Alcor if found dead or dying. You gotta remember, cryonics is a team sport. You gotta trust your team players. So at this point, they're going to quick get you into a big tub of ice, okay? And they're going to pack all the ice around you. So they're gonna try and get you nice and cold, all right? Big cold packs everywhere. Put you in one of those kiddie swimming pools. They wanna get you as cold as they can get you without actually freezing you. Because if they freeze you, as we mentioned, that creates all these sort of negative effects. They're just going to make a quick little incision right about here. Right, they're going to cut open your thigh. They're going to pull out your femoral artery, or well, really your femoral vein for preference. You can do it in either one. And they're just going to go ahead and they're going to let all that drain, all that blood, just come on right out of there. Yes, they're just going to get all your blood right out of you quickly. And then they're going to go ahead and they're going to replace that with antifreeze. All right, they're going to pump that in through a different tube, connected up to a little bag that has a big pump on it. Now, they're going to take you then to the Alcor freezing facilities. By the way, they don't like to say that you've died. They prefer to say that you have deanimated, awaiting your reanimation in the future. And you're not a corpse, you're a patient. Which is nice, I think. It's the little things that make you appreciate good customer service. Anyway, they want to get you as full of antifreeze as possible. Now, when I say antifreeze, let's talk a little bit about what that is. It's going to be, their premier solution is the M22 formulation. This is DMS, which is dimethyl sulfoxide. This is a very penetrative liquid. You can take it up just by dipping your hand in it. It'll like seep right through your skin. So this is good because we want to get this stuff spread out through as many of the parts of your body as we possibly can, especially in your brain. Now, we're also going to include some formamide. That's good stuff. And then we also want to put in some ethylene glycol. That's just straight up antifreeze. That's the same stuff you put in your car, all right? And then, maybe just a little polyvinyl, pyrrolidine, K12. All right, that's good stuff. So anyway, it's mostly these weird chemicals. What they're going to enable us to do is to achieve a state known as amorphous ice, better known as vitrified. We're going to turn this into glass rather than into ice, okay? In ice, all of the molecules are in a specific crystalline formation. However, turns out that there's another form of ice that you can make where you get it so that the ice molecules just kind of stop where they are. And they don't hook up and they don't form that lattice, okay? Because it's the lattice formation that's the real problem. That's what the extracellular ice formation. So instead it just freezes everything where it is. And then the idea is that later you can warm it up. Now we've managed to do this with small parts of the human body, all right? This is the same procedure they used to freeze embryos, that they used to freeze eggs and sperm and various types of tissue samples, cord blood, all that kind of stuff, all right? So this works on the small scale. So we're just expanding this and doing this on a larger scale. Our goal is to produce somebody who is kinetically stable, all right? So meaning that there's no motion going on in your body. If there's no motion, that means there can't be any breaking down. There can't be any catalysis. You're not going to decompose. So at this point, we get you there. We're going to take you out of the ice. We're going to get as much of this M22 stuff in you as we possibly can, cutting you open and just injecting it straight into the aorta and just really just pumping the bejesus out of us, all right? We're going to flush it all out of there. At this point, we're going to continue to take your temperature down, all right? There's a, okay, at this point, they're either going to put your whole body in a Dewar flask or they're just going to go ahead and just cut off your head. Just cut it right off and stick that into a sort of like a smaller, more like a thermos, okay? And they're going to start dousing it in liquid nitrogen. Right now the goal is we want to take the temperature down at a nice steady rate, okay? And eventually we're going to get you down to the temperature of liquid nitrogen, which is about negative 200 degrees Celsius or 70 degrees Kelvin, all right? That's really, 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 really cold. And at that temperature, hopefully we'll get vitrification, all of your molecules will stop moving, and then we're ready to just put you on ice and keep you there, all right? Now, we've been doing this for a while. The first guy who did this was named James Bedford. He looks like this. And he got cancer and he started looking like this. And he said, uh-oh, better get Alcor. He was the first guy to do it. It was kind of a messy process. He might have gone bad a little bit, but we'll find out, I guess. And he was actually pretty lucky because the next 20 or so people who underwent the process ended up, well, the guy kind of forgot to put in some liquid nitrogen for a while. So they went totally bad. Anyway, we think he's okay. They stuck him in this thing and just kept it hooked up to a liquid nitrogen tank. Then they have moved him since. All right, that's him getting moved there in the sleeping bag. And he looked pretty good then. And then they stuck him in these big tanks, okay? And you're in there for the long haul, all right? As long as, the corporation doesn't run out of money. Now, on the subject of money, this is where we run into another little hurdle, okay? The way that they set it up is that you're going to buy a life insurance policy, which when you die, will provide the funds for the whole cryopreservation process. Now, in the event that you are able to be reanimated, this would mean that the insurance company would have grounds to sue you for their money back. Then, I don't know, it's going to be fascinating when the first case of this actually rolls through the Supreme Court in a while. All right, we don't have to worry about this just yet, but it's going to be fun. All right. Now, as for the reanimation process, we really have no idea how this is going to work. The mix of all that M22 stuff that they put in there, if I can quote from Alcor's promotional literature, cellular viability by conventional spontaneous recovery criteria is low to non-existent. But ideally what's going to happen is in the future we're going to have scientific and medical technology advance to the point where we're going to be able to at least make a clone of you and maybe get your brain unthawed. The brain is very vascularized, it's got a lot of empty space in there, so if we cram enough antifreeze in there, hopefully we can save it. On the plus side though, if it works, you get to wake up in the future. You want to drive a flying car, don't you, BJ? I can see it in your eyes, in your beard. Alright, anyway, that's about it. And keep asking me more questions. I crave them.